Today we're going to be learning about multiplying polynomials, and these are our objectives for this lesson, so please pause and put these in your notes. Multiplying two polynomials. To multiply any two polynomials, you're going to use the distributive property, and we'll multiply each term of one polynomial by each term of the other polynomial, and then combine like terms. So what does this look like? So we're going to multiply the 3 times the negative 2 and the x squared times the x. So negative 6 x to the third. Remember, when we've got the same base and we're multiplying, we add the exponents. On this one, we're going to multiply this monomial by every one of these terms. And here it is rewritten, showing the distributive property. So we have 12x to the fourth minus 8x to the third plus 20x squared. Are there any like terms? No, so that's as far as we can take that one. This one we're going to multiply 2x times 7x and 5 and negative 4 times 7x and 5. Then we're going to distribute, so we'll have 14x squared plus 10x over here minus 28x minus 20. Notice we've got some like terms here. 10x minus 28x is going to give us negative 18x. Now we've got 3x plus 4. Now one thing I want you to remember, this exponent means 3x plus 4 times 3x plus 4. It does not mean 3x squared plus 4 squared. Okay, that's a mistake that's made a lot. So do not distribute the exponent. We're multiplying this quantity by itself, times itself. So we're going to have 3x times 3x and 4, and then 4 times 3x and 4. Now distribute. We've got some like terms. Be 24x here we have a binomial multiplied by a trinomial. So this a, we're going to multiply by every one of these terms, and this 2, we're going to multiply by every one of these terms. Distribute. And look here, we've got some like terms. A negative 3a squared or cubed plus 2a cubed. So we can combine those. It'd be just a plain old negative a cubed. And then the others have no like terms. Again, we're going to multiply the 3x by both those terms and the 7y by each of those terms. Distribute. We have some like terms that we can combine. And again, remember, this means 5x minus 2z times itself. So we're going to multiply 5x by both of these terms and negative 2z by both of these terms. And distribute. Here we've got some like terms, so we'd have negative 20xz in the middle as our middle term. Ooh, now we have a trinomial times a trinomial. But you can do this. It just means every one of these terms by every one of these. Here it is written out. Now let's distribute. Then we're going to combine any like terms that we see. Write it in descending order by the exponent. You can also use a vertical format in arranging the polynomials to be multiplied. In this case, as each term of one polynomial is multiplied by a term of the other polynomial, the partial products are aligned so that like terms are together. This can make it easier to find and combine like terms. So if you're having trouble locating like terms, this may be an idea for you. Then there's the FOIL method. When we're multiplying two binomials, the distributive property can be easily remembered as the FOIL method. F stands for first, then outside, inside, last. So we've got two binomials we're going to multiply by each other. We're going to use the FOIL method. The first terms, so y times y is y squared. Now, O for outside terms, the y and the 4 will give us a product of 4y. Now the inside terms, negative 12 times y would give us a negative 12y. And now to the last terms, negative 2 times 4 will give us a negative 48. Here we see our like terms. And we can combine. Let's again use the FOIL method to multiply these two binomials. First, outside, inside, last. Do the multiplication and combine our like terms. We multiplied these same two binomials together in the previous section using a different technique, but we arrived at the same product. Now for special products, and you can find special information on special products on page 287. In the process of using the FOIL method on products of certain types of binomials, we see specific patterns that lead to special products. The square of a binomial, for example. The difference, this is the sum of squares, this is the difference of squares. Notice, sum of squares, the first term is plus. On a difference of squares, the first term is negative, but the rest of the pattern is the same. A squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So all you have to do is identify what is a and b, and then you've got your answer. And then there's the product of the sum and difference of two terms. And notice our middle term disappears when there's a sum and a difference. Although you will arrive at the same results for the special products by using the techniques of this section or last section, memorizing these products can save you some time in multiplying polynomials. So you don't have to use the special products, it just saves you time. The FOIL method or the distributive method will work as well. We can use function notation to represent polynomials. Remember, or for example, p of x is equal to 2x cubed minus 3x plus 4. Remember, this does not mean p times x. Evaluating a polynomial for a particular value involves replacing the value for the variable involved. So if we're going to evaluate this function for negative 2, we're going to find p of negative 2. That means wherever there's an x, we're going to substitute in a negative 2. We're not going to do anything with this other than it shows us what we're evaluating for. So this function evaluated for negative 2 equals negative 6. Techniques of multiplying polynomials are often useful when evaluating polynomial functions at polynomial values. So we're going to evaluate f of x, this function, when f is a plus 3. So what we're going to do is we're going to replace the variable with a plus 3. It's very helpful if you just put parentheses everywhere you see the variable and then just substitute in. It might be very helpful if you mentally do the FOIL method on this one so that you can do a little spot check of your work, and also it will help you with factoring in the future. First thing we're going to do is multiply a plus 3 times a plus 3. Now we're going to distribute that 2a across that and combine our like terms. Very good. You're ready to begin work on your own.